two numbers. You are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of the nodes contain a single digit. Add the two numbers and return the sum as a linked list. What? Well, 2, 5, 7, 4, 6, 0. 3, 4, 8. Huh? 3, 4, 7, 4, 6, 10. 5, 2, 8. Oh, that's so weird, Lord. Why do you have to add the reverse order? Why couldn't they just do it in normal order? Oh yeah, let me reset this actually. Reset, start. You may assume the two numbers do not contain any leading zeros except the number 0 itself. Interesting. Wait, you may assume the two numbers do not contain any leading zero except the number 0 itself. Okay. Example 1, is there another example? 0, 0, 0. What in the world? I'll delete that, why not? And just write the boilerplate out. Add two numbers. Just a function like that. There needs to be a self because we're in a class. This is Python 3, nice. And then two list. So list 1, it's going to be of type list, I guess list node, or, well, yeah, optional list node, though we do know that they're not empty, so maybe that's not correct. Well, let's see. List node, and then, yeah, even this, like, return type should be list node as well. Like, there's going to be at least one element there. Defining class list node. We have an initializer self. We're going to have a value, we'll default it to 0, and a next pointer, I'll call it next. Default it to none. Self.value is equal to val, and self.next is equal to next. I think that's how we define, like how we set up the properties, or what do you call them? I think properties is the right word. From typing import list, or is it optional? From typing. Oh no. I think that should be correct. And then like that. Let's see. Let's reset this. Confirm. Okay, L1, L2, yeah, optional, yeah. I did kind of see like the optional before, which is why I kind of went with that. Though I have seen other examples where it would be like this as well. Okay, yeah, nice, next. Coolio. Let me keep, let me change the function parameters to match that, and let me just delete this old one to make sure everything is working correctly. Alright, so boilerplate code. We saw like an example here. So if they're in reverse order, then we want to do 3 plus 4 is 7, 4 plus 6 is 10, which is 0, and 5 plus 2 is 7. Does it carry over the one from before? How do you do that? I don't know. Is there an explanation? Oh, 342.468.807. What? Why couldn't it just be normal order? Why reverse order? Um, okay, so if I go through the linked list, is there like a hint saying like, hey, you should do this in one pass or something? I don't see anything regarding that. But like immediately well, I guess just to ensure everything is on track, list 1, list 2 both can be non-empty, so there should be at least one element in here. They're non-negative integers, so I'm assuming that means 0 and greater. What's the upper bound? Like, how long can these like lists be? What's the upper bound of the integers? Can we have duplicates? I don't see why not. And this one over here do not contain any leading zeros except the number 0 itself. So does that mean like 2, 4, 3, and then there's going to be no zeros at the front over here? Is that what this means? Yeah, okay, let's see. Constraints, the number of nodes in each linked list is 1 to 100. Values are 0 to 9. Okay, cool, so it doesn't go above 9. It is guaranteed that the list represents a number that does not have leading zeros. Cool. Alright. Yeah, brute force, or like the initial way I think of doing it, just going through, grabbing the values, going through, grabbing the values, doing the addition, and then taking each of the digits, and then putting them into a linked list. I guess we can put them like 807, like kind of point like 807, and then do like a reverse linked list on this to make it in this format. Again, that's like a lot of passes. Maybe that's not the best way to go about doing it. Is there a way to do this in one pass? I mean, 7, 6 plus 4 is 0, and 3 plus 4 is 8. But then the 1 carried over from before. We gotta like keep track of that somehow. So we're going through both of these at the same time, and then going in this order as well, so it's just one pass. I think that's a better way of doing it. In terms of the time complexity for both was O(n). It's just that my initial approach was just, it had multiple passes, multiple, like I was reversing, I was going through one and then going through the other. Whereas the second approach with like going, 2 plus 5, 7, 4 plus 6 is 0, kind of keeping track that we have a 1 carried over to the next. Maybe like a carryover boolean or something, because we can never have 2. Like it'll be 6 plus, like the most we'd have is 9 plus 9. Which is 8, 1. Actually, let me check that. So 2, 5, 9, 9, 3, 4. So that's 3, 4, 3, 4, 2, 4, 6, 4, 5. Sorry, give me 1 second. All right, cool. Okay, so whoa. So 3, 9, 2, 4, 9, 5. Add those two together, we get 7, 8, 1, 8. Yeah, so still like 1 still being carried over. So 8, 8, 7. Yeah, okay. So cool. Time complexity, I talked about linear time. Space complexity, I think this would be linear. No, constant. Whereas before, when I was like holding the original list and then reversing it, that would be linear because I'm adding an additional data structure. Let's try. Let's give this a shot. So we want a current 1, current 2, and we want to make sure that we're going through both. Both of these are going to be the same length, by the way. That's another good clarifying question to ask. I don't think it's necessarily true, actually. Yeah, I don't see any constraints saying... Oh, there we go, yeah. Yo, lining up the numbers, like, you know, like this is how you line up numbers and then you add them up. But lining them up in reverse is so weird. I gotta like write it out like this. 9, 9, 9, 9, 9, 9. Right, and then 9, 9, 9. And then you put it at the end of like that when you're adding them. And then you kind of go from there. But then the 8 was in front here, over here is at the back. Okay, cool. So while cur1 is not equal to none, and cur2 is not equal to none. Okay, and then we'll have to have like a check at the end to see whatever remaining elements there are in cur1 or cur2, we just kind of deal with them. In that case, we don't even add, we just add them with 0, like, or we just, you get what I mean, like it's kind of like this scenario here, right? You're not really adding anything to it. Other than the potential carryover from before, like for this example. So we want like a sum. So cur1.val plus cur2.val. And we want new cur. So we'll do something like result list node, and new cur is equal to hold on. Yeah, okay. Like that. So new cur dot val is equal to sum, and new cur. Okay, let's deal with these two things first. So cur1 is equal to cur1.x, and cur2 is equal to cur2.x. Right? So we've iterated to the next index, and then new cur dot val, cur new cur is equal to new cur dot next, or actually, this node sum node, and then set next to be equal to node. Nice. And then at the end over here, we'd want to return new cur res.x. Okay, and then if cur1, then we'd want oh wait, hold on, I have to deal with the carryover. Carryover is equal to false. And then the sum. If sum is greater than 10,